Hello and welcome. I am Saptarshi. In this video, I will explain what are unit vectors and how they are related, how they are connected with the vectors. So, suppose at this position there is your school and this is your house. So, if you want to reach your school, then you should start from here and then you should move towards this direction. Okay. So, suppose this distance is 400 meters, so you should travel a distance of 400 meters to reach your school, right? So now suppose instead of going in this direction, you are moving along this direction. Then you won't be your school, right? You will be at this position. This is not your school. So similarly, if you are moving like in this direction, the same 400 meters you are traveling, but you won't be at school. You will be somewhere here. Okay, so if you are moving the same 400 meters along this direction, you will be somewhere here. And if you are moving along this direction, you will be somewhere here. If you are moving 400 meters along these directions, you will be somewhere here. So these are not the destinations. Okay. So to reach the destination, you should have a particular direction. And in this case, it is the north direction, right? So if you are only considering this 400 meters, that doesn't mean that you will be at your destination. You may be in some other different location, because you are, if you are only considering the distance, you are traveling this distance, but the direction is not given. It may be anywhere. Okay, any direction it can be. So to make sure that you are reaching your destination, you should add this direction with this distance. Okay, so this is basically called the magnitude. This is the magnitude and this is the direction. So if we are combining both the things, the magnitude and the direction, now it will become the vector quantity. Okay, this is the vector quantity. So for a vector, it should have a magnitude, the value of the vector. So you should travel 400 meters. Along with that, it should have a direction where you should travel, in which direction you should travel. So combining this, this is a vector quantity. Basically, this is the displacement vector you should follow to reach your school from your house. Okay. So if the direction was not here, then you may be at a different location. Okay, so you should have both the magnitude, both the distance and the direction to reach the destination. So this is the displacement vector you should follow. Now suppose this is your friend's house, and if he wants to go to school, then he should follow this direction. Okay, 300 meters the distance, and he should follow this direction. This is the eastward direction. Okay, so this is the magnitude and this is the direction along the east direction. So this is the vector quantity. Okay, this is the displacement vector your friend should follow. So these are the vector quantities, these are the displacement vectors, because they have the magnitude, the values, along with that they have the directions also. So this is the vector quantity, this is the displacement vector you should follow, and this is the vector the displacement vector your friend should follow, right? Now, if I consider these directions, this is the north direction, this is the south direction, this is the east direction, and this is the west direction. So suppose I am replacing this east direction with the x-axis. So this is the x-axis, and the north direction is replaced by the y-axis. So this is the x-axis, this is the y-axis. Then, if you want to go in the west direction, it is opposite to the positive x direction. So this is the negative x axis. Okay, and the south direction, it is opposite to this axis. So this should be minus y. So these are the axes I have replaced. Okay, the direction. So I can replace this north direction by y axis. Okay, this is the y axis. So I can write y instead of north. And for east, I can replace it by x. Okay, so now you should travel 400 meters along the y-axis to reach the school, and your friend should travel 300 meters along the x-axis to reach your school. Okay. So now, if instead of x, I am writing 2x, so that means x is the coefficient is 2 for x, then there should be 300 meters multiplied by 2. If I am replacing x by 2x, then it should be 300 meters into this 2, so it should be 600 meters. So this is the 600 meters from the location. Okay, so your friend will be somewhere here, right? So this is not the destination he wants to go to here, but instead he will be at somewhere at this position. So this is not correct, right? So that means this the magnitude of x should be 1, so that the 300 meters should remain 300 meters. It should not be 600 meters or anything else. So then only your friend can reach the school. So the magnitude of x should be 1. So this is showing the mathematical expression. So this is the modulus. This sign is showing the modulus or mod value of x. So basically that means the magnitude of x is 1. Similarly, the magnitude of y should be 1, because you also have to travel 400 meters. If the magnitude is different, is suppose 2, then it should be 800 meters. That is further away from the location. So that means the magnitude of x and magnitude of y should be 1. So these are called the unit vectors. And for unit vectors, we write x hat, y hat, or you can say x cap, y cap. Okay, so this x hat and y hat are the unit vectors because the magnitude of these vectors are 1. Okay, so that's why they are called unit vectors. Basically, one means unity. Okay, so from there we can say that these are the unit vectors. And why vectors? Because they are indicating the direction. Okay, y means that is along the positive y axis, and x means along the positive x axis. So these are the unit vectors. So x hat is the unit vector along the x direction, and y hat is the unit vector along the y direction. More specifically, you can say x hat is the unit vector along the positive x axis, and y hat is the unit vector along the positive y axis. Okay, so now this 400 meters y, this is not the correct notation to write. So instead of this, we should write 400 meters. This is the magnitude, and y hat. Y hat means its magnitude will be 1, so that it won't affect the 400 meters. The distance will be 400 meters, but it is giving one direction along the positive y axis. So this is basically the thing. So one thing you should remember, that you should not say that the unit vector doesn't have any magnitude, because doesn't have means the magnitude is 0. So then 400 meters multiplied by 0 will be 0. So the magnitude of y is 1. You should not say that it doesn't have the magnitude, but you should say unit vector has a magnitude of 1. Okay, so this is the unit vector, magnitude 1, but it has a particular direction. Similarly, the 300 meters x, that should be written as 300 meters x hat, that is along the positive x-axis. Okay, so I have changed these things here also. So 400 meters y hat and 300 meters x hat. Okay, now suppose there is another student whose house is at this position. So if he also wants to go to school, then he first should move along the 300 meters along the x-axis, then 400 meters along the positive y-axis. Then he will reach the destination. He will reach the school. So this is the vector which is indicating this displacement vector of this student. Okay. So now this yellow line, this is actually showing this vector here. So the concept is, if you are moving along this line, you are covering both the x-axis and y-axis also, both the distances you are covering. So you can see that if you are moving along this direction, then you are moving along the positive y-axis, so that should be y hat. And if you are moving along this line, so this is only the x-axis. Okay, you are moving along only the x-axis. But if you are moving along this path, both you are traveling along the x direction and along the y direction. So both the x and y axis distance you are covering when you are moving along this direction. Okay, so this is basically this vector. Okay, now I want to find the displacement, how far the student should move to reach the school. Okay, one thing is, so if you are going like this axis, how it is this vector quantity. So if you are traveling like this and then this, you are reaching at school. And here also, if you are moving like this direction, then also you are reaching the school. So the end point is the same. So that basically means if you are moving like this direction, you are covering both 300 meters x hat and 400 meter y hat. So basically, moving like this will give this vector quantity. Okay, so that's why this is the vector. So now what is the distance? Okay, to find that we should use the Pythagoras theorem. Now suddenly how the Pythagoras theorem came into play? So basically, this is the x-axis, this is the y-axis. So they are perpendicular to each other. So this triangle is basically a right angle triangle. Okay. So this is 90 degree. So that means we can use the Pythagoras theorem on this triangle to find the distance. This one. Okay. So this distance is 500 meters. How? The displacement will be square root of 300 square and 4 plus 400 square. So that will give 500 meters. So now you can see you are eventually reaching your school. But if you are moving like this, so this is 300 meters, then 400 meters, so that will be 700 meters. This is 700 meters. So this is the total distance if you are following this path. But if you are moving along this path, it is only 500 meters. So this is called displacement. This is the shortest distance between 2 points. So this is one point, his house, and this is end point, the school. So the shortest distance is this one, and this distance will be 500 meters. But if you are moving like this path, this is 300 meters, this is 400 meters. So the total distance will be 700 meters. But if you are moving like this is the shortest distance between this point, and this is called the displacement. Okay. Now we can write this vector as this one. So this is a vector form. This is not the magnitude, this is a vector form. And the magnitude will be 500 meters. Okay. So now, instead of 300 meters, in general, I am writing AX. So this is one general form, the AX, and this is y hat. Okay. Then the vector, this vector will be AX, X hat plus y hat. Okay. So this is the vector quantity. Vector A equal to AX along x direction, this is the unit vector, plus y hat. And what will be the magnitude? By using this formula, it should be square root of ax square plus ay square. This is the magnitude. Okay, this is the magnitude, how far that the student should travel, and this is basically the vector quantity. And you can see here, if you are moving along only x-axis, there is only x hat. If you are moving only along y-axis, it is y hat. But if you are moving along this, so both the x hat and y hat should be there. Some part of x hat and some part of y hat. So both the direction will be there. It is not simply x hat or y hat. Okay, so basically you are covering both x-axis, x values, and y values also. So this is the vector quantity. Okay. Now this is the vector quantity. This is the magnitude of the vector. So now from the previous slides, what we have learned that if you are moving ax distance along the x-axis and ay distance along the y-axis, then the overall vector quantity will be this. Okay. The overall vector quantity will be this. That is the vector A equal to AX x hat plus AY y hat. So now, if the direction is the same of this component, these are called components. This is the y component, okay, along the y-axis. This is the x component along the x-axis. So these are the components of the A vector. You can see this is the one component along x-axis and another component along y-axis. So if the direction of the component and the magnitude of the component remains the same, then you can move this one. Okay, so you can move this one. So you can see that the direction is the same along the y-axis, positive y-axis, and the magnitude also I am not changing. So you can move this one, and similarly you can move this one also. You can move this line at here also. So you can draw like this also. But yeah, I have moved the y component. So if I consider the vice versa, then if I am giving you any vector, a vector, then you can divide that into two components. So one along x-axis, another one along y-axis. So this is basically the vector component, and you can write the overall vector as the vector components. Okay. So yeah, you can further see the other things of the component, how we can break any vector in the component forms. For that, you can consider one angle. Here you can consider theta, and then you can use the trigonometry to find the exact values of the component. Ax will be a cos theta, and ay will be a sin theta. I am not going in those things in this video, but you can do it later. So in some cases, you can see x hat and y hat. Those are the unit vectors along positive x-axis and positive y-axis. But in some textbooks, you can see instead of x hat, they have written I hat. And instead of y hat, they have written j hat. So they are basically the same thing. You can write x hat also, or you can write I hat also. Similarly, you can write y hat, or you can write j hat also. Okay, so by convention we usually write I hat to show the unit vector along the positive x-axis, and we write j hat to show the unit vector along the positive y-axis. This is by convention we are using. So in these notations, so we can write the overall vector like this. So the x hat I can write I hat, and the y hat I can write j hat. So this is the basic thing. Both are actually the same thing. You are using x hat y hat notations, and here you are using I hat and j hat notations. That's the thing. And the magnitude will be the same: ax square plus ay square. Okay, square root of x square plus ay square. This is the magnitude of the vector. So now, if you are returning back to your house from the school, then you will head towards the south direction, that is opposite to the north direction. So then you are still traveling 400 meters, but in the opposite direction, in along the negative y-axis. So that should be 400 meters minus j hat. Okay, that should be 400 meters minus j hat. Similarly, if your friend is returning back to his house, then he is moving along this direction. So this should be 300 meters minus I hat. Okay, this is along the negative x-axis. So these are all about the unit vectors and vector quantities, how you can write any vector by the unit vectors and the components of the vectors. Okay, and then you can see the other concepts of vectors also. But in this video, I just tried to explain these things. Thank you for watching. Hopefully, you have enjoyed the video and you understood this concept. So thank you. Have a great day.